This conference will now be recorded.
Good morning, good evening, based on wherever you are. Welcome to the demo. My name is Kiran, and I thank you all for joining this demo. So let's get started. Hope I am loud and clear. Everyone can hear me. Could you please confirm?
Yes, I can hear you.
And I think you can see my screen as well.
Right, yes.
Thank you. Uh, so about me, I have about 10 years of experience in DevOps and site reliability engineering roles. If you don't know what SRE is, we'll come to that. Don't worry. I'm passionate about technology and training and teaching. I'm a movie buff and occasionally read books. That's about my personal side. And my areas of interest are container orchestration, cloud automation, and free and open source software and Linux. Okay, so we'll come to the point straight. So what is this course about? What do we do in this course? Okay, so very high level view of what we do, get a clear picture of IT operations and how applications are deployed and maintained. Okay, gain understanding of key Azure services, learn and apply DevOps toolset, DevOps toolset, gain deep knowledge of IT operations and software development lifecycle processes. So this is at a very high level, okay, but each of them has, that doesn't mean we will be going full theoretical on this. There will be a lot of hands-on. I mean, most of the classes are hands-on, right? So this course name itself is DevOps with Azure. So Azure, as you know, is a Microsoft's cloud offering. So let's understand what cloud is. Okay, could anyone define what cloud is from what you know? There's no right and wrong answers, so please feel free to speak up. No takers. All right, then let me do it myself. Uh, Cloud computing is the on-demand availability of computing resources. Okay, so what does that mean? So back in the day, when you have to, let's say, you have a good idea of starting an application, okay, but if you want to start a web application, simple web application that gives people, let's say, information about postal codes or information about, you know, historical events or whatever, you want to just start a small website as a hobby, okay. But if you want to you know start that, you need a server to host your application on. You cannot host your application, hosting in the sense you cannot put the code of your application on your own machine or on your laptop or your desktop. It has to be in a dedicated system that is capable of running 24/7 365 days, right? Even if it's a hobby website, you don't want people to see downtime all the time, then no one will come to that website. So then you have to buy a server. You have to make sure it has a redundant power connection. Redundant power connection is a secondary power connection, like an inverter or a generator, something like that. And also you need to have a redundant network connection. You cannot rely on these network providers, right? They might go down anytime, because uh, they have every service provider has some downtime. So if you have something like AT&T in the US or Verizon, you want to have something else as well, a secondary provider. Even in India, if you have, let's say, Act, you might want to also have Airtel, because if Act is down, you have Airtel working for your server. So you have to invest in all these money, and let's say your website has not clicked, then you don't know what to do with this server. You spent maybe 200,000, 2 lakhs Indian money, and it's still lying there. You don't know what to do. Okay. Or let's say if your application is picking up and it's growing in demand and more people are coming, then you have to buy more servers. So while you have to place the order, the server has to come to you. And in this time, what happens? Your customers might lose interest because your website got slower. More and more people are coming, the website got slower. And by the time you buy a new server, people stop coming to your website. Okay. So this problem is solved by cloud computing. Okay, so it's an on-demand availability. You just go into a website and log in and click, and uh, create a virtual machine of any size you want. Like, and when I say size, not the physical size, but the specifications wise. Like you could take a 8 GB virtual machine with 6 cores of CPU or 8 cores of CPU, or you could take a 32 GB RAM computer with 16 cores of 32 GB of RAM with 16 cores of CPU. So it's just like at a few clicks you can buy a new virtual machine. You can rent a virtual machine, not buy actually. You can rent a virtual machine and use as long as you want to use, and shut down when you don't want to use it. Okay, so that's not only just a server, even hard drive. You want to store like 1 TB of data, of some business critical data, and you don't want to trust your, let's say, external hard drives. You want to make sure it is persistent, it doesn't disappear because of any corruption issues. So what you can do, you can go to any cloud provider like Azure, Google, or Google Cloud Platform, or AWS, and provision a hard drive for yourself. And using internet, you can store all the data there, and it will be safe. Okay, that's what it means by on-demand availability. Just with a few clicks, you have the computers available. Okay, so what is cloud actually? It's on-demand availability of computing resources. That's fine. Computing resources could be, virtual networks, virtual machines, hard drives. Okay, virtual hard drives, anything. Okay, but underlying that, there should be some physical infrastructure, right? There should be physical infrastructure where these servers are hosted. So in other words, cloud is not nothing but a collection of data centers managed by a cloud provider. Meaning, in the earlier days, like if you take any companies like Citibank or JPMC, or any big auditing companies like KPMG, uh, all these companies still maintain their own data centers. Meaning, they buy their real estate. Okay, they put their physical servers there. They hire a data center team. They will manage everything. They manage everything even today. Okay, but as I told you, the one of the important reasons also for the startups to boom is this cloud. For example, Flipkart doesn't have any of its data centers. Flipkart's servers are all hosted on AWS, meaning Flipkart uses AWS to run their applications. Okay, so is the case with Netflix. Netflix has zero, I think, zero data centers. They don't have any. Data center is nothing but where you put all your servers, your cables, switches, routers, all these hard drives, and all that stuff. Okay, even Netflix doesn't have its own data center. Netflix also uses AWS. So instead of these companies managing their own data centers, they will rent resources from AWS. One important AWS or Azure. One advantage for them is they don't have to kind of create a separate team for maintaining data centers. They don't have to uh, check if I need new hardware, because AWS and Azure on Google Cloud Platform and all these things, they host such large data centers that any demand can be fulfilled literally. Okay, um, that's why cloud is nothing but a collection of data centers. Instead of you managing it, a cloud provider manages for you and also many other people. Okay, but they offer isolation from one person to another person. Like, it's as if you have your own data center. Okay, when you're using cloud, but it is maintained by AWS or Azure or Google Cloud Platform or Alibaba Cloud, a lot of other clouds, right? Users can rent resources on a pay as you use model without the upfront cost. All right. Back in the day, I mean, again, coming back to the earlier example, when you wanted to start a website, you have to buy a server, okay, and you don't even know your website will click or not. You already bought the server, you already bought the additional inverter, you already subscribed to additional network connection and all these, but within 10 days your website fails and you don't know what to do with the server, as I told you, right? That's an upfront cost. Upfront cost is the cost you have to put even before you start your project. But here there is no upfront cost, meaning when you rent a resource, when you create a virtual machine for yourself on Azure, you don't pay the money upfront. You can use it for 1 month, or you can shut it down after 10 days or 15 days, or even you can continue after 30 days also, but your bill will be paid after the first 30 days only. And for what you used, for instance, first 10 days you started with a simple virtual machine of 4 GB RAM and 2 cores of CPU. So you only your friends and family are using your website, and they forwarded you about your website, which is really cool, and a lot of people started using your website or app. Okay, so now you need more capacity, more and more. Is there a question? Just can everyone mute please, unless you have a question. Okay. पता नहीं. So yeah, so you will pay for only how much ever you spend. Let's say for first 10 days you used only one virtual machine, and the next 15 days you thought the load is increasing, so you bought additional two servers. Okay, so for the first 10 days you'll pay only for this one server. For the next 15 days you'll pay for the additional two servers. Now you know that you have improved your application and you know two servers would be enough. So you decommissioned the other server or you deleted the other server. So now you will pay only for two servers for the rest of the 5 days. So in this way, you're paying only for how much you're using. Okay, just like your electricity billing. Okay, you don't have a fixed cost, right, for your electricity billing. Of course, there is some underlying service charge and all, but here there is always pay as you go. You will pay only how much ever you use. Okay, if you shut down the servers and delete the servers, you don't have to pay anything at all. All right, that's what pay as you use model. Of course, Ola and Uber are examples for pay as you use. Earlier we used to bargain with the taxis and say, okay, I need to go to from place A to place B, how much will you charge? He would say, oh, it would cost me 300 or something. But now you need not even, you can even change the destination midway, and your billing will be as per the distance traveled and not any predefined cost. That's what it means by pay as you use model. Any questions? Okay, before we go to the cloud types of cloud services, I just kind of give an example um, about I mean the real world definition of cloud. Okay, so how awesome life would have been if everything is cloud in real life also. Let's say you have a retail store, a physical retail store for clothes. You have an apparel shop where you sell clothes and other things, and of course you need a store warehouse where you store all your supplies, right? Because you cannot keep everything in the shop. In the So let's say you have a shop in Abbots and you have rented a shop in Koti. Okay, so this is, let's say, 100 square feet, 100 square feet of room where you store all your clothes and all that stuff that you need to sell. Okay, so let's say at any given point time you use about only 60 feet of your resources. Okay, 60 square feet of space you use. Rest of the year, the 40 square feet is gone waste. Okay, so this is about elasticity of your cloud. Okay, but let's say again, come December, due to Christmas and other seasons, your demand increases by 80 square feet. Okay, so 20 additional square feet, but even then 20 square feet is gone waste, right? But you cannot go for a shorter ones. Let's say the shorter ones about 50 square feet or 40 square feet, and you're not getting anything above 60 square feet, because at the maximum you would need 80 square feet during the festival season. Okay, but even then 20 square feet is wasted. No one will rent, no one will take it for rent from you. Okay, so imagine if the life were to be very simple, like when you want, you can only pay for 60 square feet. Okay, and when the demand comes, you can increase up to 80 square feet, and you'll pay for 80 square feet only during that month where you increase to 80 square feet. Remaining months you'll only pay for 60 square feet. Okay, and if it further increases, maybe you can there is elasticity that you can further increase to, let's say, 100 square feet if there is demand, or 120 square feet. Imagine the same shop seller, if his demand goes to 120 square feet of space for his clothes, he has to rent another shop. If not, if it is possible to extend as much as possible or contract as much as possible, say after lockdown there is a shortage of sales, so he needed only for 40 square feet because most of the stock is already sold over and he doesn't want to get new stock. So if there is a way where he could only reduce to 40 square feet and pay only for this much, how life would have been very awesome, right? But in physical world we cannot do that because it's not so easy to physically uh, change things and get for only that much range. But in computers you can do that. For instance, again the same example, you start a you start an application with two CPUs and 8 GB of RAM, and demand increases, you create another such server. uh, okay, and demand further increases, you increase one more server. Okay, I mean correspondingly you will also increase hard drive space and all that stuff also. I'm just talking about servers here. So you go on increasing till till an extent, then your demand stabilizes. In the sense, not many people come to your website now, but there is a steady increase. Then for the first 2 months, let's say you're doing with only these two servers, you will pay only for these two servers. For third month, you're using three servers. Okay, then you will pay only for the three servers. From there, you'll pay for the additional total five servers for how many ever months you're running. Okay, then after some time you decided to take away two servers because your load has stabilized two servers. So now you will not be built for these two additional servers, you will be built for only these three servers. Okay, and you don't have to worry about their maintenance, where do I keep them, okay, and all that, because it's all maintained by your cloud provider. Okay, you delete it, you forget it. Okay, if you want to back up the data, you can back up the data somewhere and delete the servers and forget about it, and you have these three servers doing your job. Okay, let's say you want to suddenly do a promotion during the festive season, like Amazon, uh, you know, Amazon Big Billion Sale or Flipkart Big Billion Sale. So you decided to get a very big computer, like or tens of computers. Okay, 20 new virtual machines with you know eight virtual CPUs and 24 GB of RAM. Okay, so you decided to buy 10 virtual machines. In real world, I mean, if it's in the old case when you don't have the cloud, to procure them itself will take a lot of time. You have to first make a call to Dell or IBM, not IBM, Dell or HP to prepare these servers, and they'll get to you, and you have to install software, and there's a lot of time wasted here. But in cloud, you within seconds or within minutes, in fact, you can provision new servers of whatever capacity you want. Or let's say you want to do an analytics of your sales data, and it requires, let's say, machine learning, right? We are using machine learning to calculate, let's say, or treat trend analysis. What is the trend analysis? Which age people are coming in what time in to my website, and what are their interests? Which product should I promote more? Okay, then you have to use some machine learning module. Let's say you want a computer that has 100 cores of CPU, 100 CPUs, uh, and 100 CPUs in the sense 100 cores. Okay, like we say quad core, dual core, octa core, right? 100 cores, and 1 TB of RAM to do the processing. Okay, imagine if you have to buy this big computer, even these hardware manufacturers also don't have it ready. They will prepare these on demand. Okay, but in cloud, you can get it in a matter of minutes. And let's say you use it only for 1 hour or 2 hours. To buy this big size computer with such specifications is a lot of cost if you don't have cloud. But on cloud, you can provision this infrastructure within minutes and start using it for, let's say, 1 hour, and decommission it or delete it, and you can forget about it. So that's the elasticity of cloud. You can go from very small computers to very high computers, and only you can use it for hours and only pay for those hours. Let's say you used it for 2 hours, the billing was like $200, and you delete it, you'll pay only those $200 at the end of the month. Okay, unlike your traditional method where you have to buy this system, keep it somewhere, maintain it all the time. All right. So and trust me, there are some billing, some systems which are billed per second also. AWS has brought in per second billing for Linux virtual machines, meaning if you use per 2 hours 30 minutes 15 seconds from this and stop it at 15th second, I mean 2 hours 30 minutes 15 second, you'll not be billed after the 16th second. That's how precise the billing has become. Okay, I mean, for one computer that might not show any impact, but imagine 10 computers are built on the seconds basis. You might be using 10 computers sometimes, you might be using 5 computers. Computers or servers are the same. Okay, so that's how elastic cloud can get. All right. Any questions? All right. Cloud itself has become a very commonly used word for a lot of services. But within these services, there are three primary categories of services. Okay, one is IaaS, another one is PaaS, and another one is SaaS or SaaS. So what does this mean? Infrastructure as a service, meaning here we have so far talked about that kind of service only, where you want to host your application, you know everything about operating system, you know everything about deploying applications, and also you are a developer. Okay, or you have another friend who is a developer, he can develop the code for you. So IaaS is where you rent your virtual machines or hard drive, or even the network. You create the infrastructure, you maintain them. Okay, of course the infrastructure, the physical infrastructure, the servers behind these virtual machines are maintained by Azure, but you will take care of running the you'll take care of that virtual machines, the operating system inside it, the security patching inside it, whatever software you need to install, you will take care of it. Okay, so you have control over your infra and also application. That is IaaS. Okay, so IaaS typical example is virtual machines, virtual network, and disks. The positive side is you have total control. The negative side is high management overhead, meaning you need to have people who can manage these virtual machines on cloud. Okay, and also you need to take care of the security patches and all this stuff. Next one is PaaS or platform as a service, um, which is also known as developer services. The reason it's called as developer services is because let's say you are a very good developer, you know how to build a nice application, but you don't want to install the application all yourself. You don't want to deploy the application on the server because you don't know anything from the operations point of view. You don't want to take that pain of learning about operating systems. How do you install? How do I configure my logging? You don't want to do all that. You are a good developer, you can build a nice application, you know how to compile it. So you will compile that, or you will build that code and give it to the cloud provider, and they will host it for you. Okay, so you can forget about the underlying infrastructure, like what virtual machine are they using, or what operating system are they using, what version of Java is running. All these things you can forget about it. You can just worry about your code and forget about the infra part. Less control. The positive side is worry only about your dev activity. You can focus only on developing your application instead of worrying about I need to do security patches, I need to do OS upgrades. All these things you can forget about. The negative side is less control over infra. So if you have any custom need, like you want your operating system to have certain logging enabled or something like that, you cannot do it in platform as a service. But for simple, there is a simple application that doesn't require much configuration on the OS side, you can use PaaS. Okay, next one is SaaS, which we all might have used in our daily life. We all are using SaaS in one way or the other. So SaaS is software as a service. Okay, let's say you are a company which specializes in let's say auditing, financial auditing, but you have a big company, and all your team members should also get educated on the various auditing laws, compliance, and all these things, right? So you need a learning management system where people can go and subscribe to courses, learn and track progress and all these things. You can hire a team to maintain a learning and management system specifically for you. Or what you can do is you can speak to someone like LinkedIn Learning or Pluralsight or Linux Academy or any of these Udemy, any of these training providers, and tell them, hey, my company has so many folks, all of them need access to certain courses which are offered by you, and also we will also host some courses of ourselves. Okay, I mean, we have our own courses, we want to host them on your platform, but only for our employees. Okay, so what is the contract? So the Udemy folks or the Pluralsight folks says, okay, for 2 years for 1,000 employees, this is how much we'll charge. Okay, if it's an enterprise, even more users, like 100,000 users, so this is the contract for 10 years, where your people can use all the courses on our platform, and also you can host your own courses. So here in this case, the code is maintained by Pluralsight, the infrastructure is also maintained by Pluralsight. All that you need to do is you will get a website to log in and give access to people, your own people, and they can access and start using it. Okay, that's what SaaS is. Here you don't develop the application, you don't write code, you don't also maintain the servers. Everything is maintained by the cloud provider or the service provider like Udemy or Pluralsight. Or let's take another example also. Let's say you are a startup, you are a ML machine learning based startup. You build applications for data scientists, but your team needs what they call the payroll, right? Payroll team, you need a payroll site where people can download their pay slips, where people can upload their tax information and all this stuff. Where do they do that? Okay, so they have to have a central site. Why do you have to? You are already a startup, why do you have to buy a I mean, hire a new team to create a site only for payroll? You can go to someone like Zoho, they are HR Workways or a lot of other services, right? So they will give you an admin access to your admin. He can log in and give access to all your employees, and he can upload the pay slips and everything. He can do it. Okay, that's an example of SaaS solution in the office, in the work wise. In our real life also, we are using a lot of SaaS products like Google products like Gmail or even Google Drive. All these are SaaS products, right? You don't host the application anywhere. You don't write the code. Everything is managed by Google. You just subscribe to the service and start using it. Okay, that's the SaaS solution. So these are three kinds of services: IaaS, PaaS, and SaaS. Okay, as you see, as you go from IaaS to PaaS to SaaS, the control decreases, but the ease of management increases. Meaning, you don't have to worry about maintaining the code. You don't have to worry about maintaining the applications. You can simply focus on your business activity. Okay. Um, there are advantages, as I told you. If it's not your area, you need not get into it. That's the idea of SaaS, right? Like if you're building one, let's say in your real life, let's say you're building a home. No, I'll give, yeah. Anyway, so I hope you understood. Okay, some people say that IaaS is like doing your own pizza. Okay, platform as a service is like uh, going to ordering pizza from your pizza store and eating at home. Meaning your chairs, your table, but pizza is someone else's. Okay, SaaS is where you go out and dine in Pizza Hut. You don't have to worry about cleaning your tables. You don't have to worry about bringing water for yourself. Everything is ready. He will just place the order and he will get the pizza for you. Okay, that's like it. Which one you want to do? You want to buy a ready-made dough and make pizza at home? That's IaaS. You want to order pizza and eat at home? That's PaaS. Okay, you want to not worry about even cleaning your home and directly go and eat? That's SaaS. Okay, uh, and each of them has different levels of management practices. We don't worry about SaaS because SaaS is just an admin task. We also don't worry about PaaS in our course because this is more like developer services. We are more focused on IaaS. So we will focus more on infrastructure as a service aspects, like the virtual machines, virtual networks, how do they interact with each other. All these things we'll focus on our course. Okay, so I'll take a pause and see if you have any questions. All right, let me see if there are any questions in the chat window. None. Okay, thank you. All right, so we'll move further. Okay, what is Azure? Now, we already talked about cloud, a lot about cloud, right? So why do we have to speak about Azure? Because the course is about Azure. So Azure is Microsoft's cloud offering. So Microsoft has many offerings, and Azure is one of their leading cloud offerings or primary cloud offering. And it is one of the leading providers of cloud, only behind Amazon's AWS, okay, in terms of market share and also in terms of service offering in the sense, in the in the area of, in the number of services also, um, Azure is just behind AWS is the market leader because it has started much earlier than Azure or Google Cloud Platform. AWS has started in 2006, in fact. Okay, Azure has started in 2010, but there were some initial hiccups it tried to pick up, but now it's one of the fastest growing cloud service. A lot of people are moving, a lot of enterprise customers particularly are moving to Azure. In terms of growth, Azure is growing faster than AWS is like consolidated, like it became a saturated point where a lot of people already started using it. Okay, Azure, more and more people are adopting cloud. So when today, when people want to move towards cloud, they have a lot of they have a lot of options. They earlier it was standard. AWS was the primary choice. Now they have AWS, Azure, Google Cloud Platform. They have DigitalOcean. They have Alibaba Cloud, IBM Cloud, a lot of clouds. But again, even in this competition, Azure is standing very firmly. Um, Azure's infrastructure is spread across the globe in 54 regions. It's an older one. Actually, it's more than 60 regions in about 150 countries. Azure services span various areas such as virtual machines, storage, machine learning, IoT, big data, security, and many, many more. Okay, so it can start with a simple virtual machine to a big data application to Internet of Things. You can get everything on Azure. Okay, this is the Azure's infrastructure. Um, So these are all Azure's data centers where Azure hosts its data, okay, or its servers and physical servers, actually, the physical boxes that you need to use to maintain your virtual machines and everything. Okay, so primarily focused in the North American region and some in the European region. Good presence in China and you know, the Middle East and India, and yeah, also in Australia. It's picking up. They're coming with new regions. This is an older one, but let me show you the current one. So this is how your data centers look like. Okay. Um, I mean, this is still under construction, perhaps, but inside these you'll have servers like these, tens of servers. This is your cooling system, which keeps your servers cool all the time. Okay, this is a big console through which you can check your servers' health. I mean, we don't have to check them. Azure will check for us. See, these are all racks where you put in your actual servers. Uh, let's see. Yeah, so this is the latest picture. My picture is a little outdated. I should have updated it. Okay, so look at this one. There are various regions that are coming up. These dotted ones, these are nothing but new regions that are coming up. Okay, so there are some blue ones. There are blue ones with rhombus. What does that mean? So there is a concept called as availability zone. Okay, so an availability zone is nothing but a group of data centers, something like this, a big complex of data centers. Okay, it's called as a availability zone. So when providers start a region, when I say region, they they start in a particular city, or a big city like Chennai or um, Mumbai or anywhere. What they do is they choose two different locations. Okay, they host their locations within the city in two different locations. Okay, for example, if they're doing it in Hyderabad, they'll do it in one side of the city, like Ramoji Film City. They will install one one data center or one data center complex group of data centers, and another one they will do it somewhere at Patancheru or Medchal, so that the two are isolated from any kind of issues. For example, if Medchal is flooded, they still have the Ramoji Film City, or if there is some sort of let's say disturbance, riots or something in Ramoji Film City area, you still have your Medchal running, and these are connected with their own cables, not over the public cable. So it's as if they're a single data center, but separated from some distance. Okay, so that's a region and availability zone. A region is a specific geographic area, like a city like Hyderabad, or you know Oregon or something in or California in the US, whereas availability zone is a complex data center complex within that city. Okay, so Azure has only some areas where you have availability zones, meaning more than one data center in one region, but most of the regions have only one data center. Okay, but they're catching up nowadays. They're going to increase the availability zones as well. Okay, so these are the various regions where Azure operates. Again, particularly focused in US and Europe, unsurprisingly, because most of the business is from there, financial services and manufacturing, everything is located in Europe and US, right? And of course, China and some in Japan and Australia as well. Okay, and recently you might have seen a big announcement about AWS making a large investment in Hyderabad, some 2.7 billion or something. Did you read that in the news? In Telangana region, AWS is making a big investment. You haven't? Okay. So what they're doing is actually bringing in a new region in Hyderabad. Again, it will have 2 to 3 data centers, 2 to 3 availability zones or data centers. All right. So that's the Azure spread across the various regions. Okay. So that's about the Azure side. As I told you, it's the second most leading cloud provider, and in terms of market share, meaning in terms of the number of users using it, and also uh, in terms of the services, number of services, it is in second place right now. All right. So let's move on to the next concept, the DevOps concept that we want to talk about. Okay. So let's see what it's all about. Okay, so DevOps is a set of software development practices that combine software development and IT operations to shorten the system's development lifecycle while delivering features, fixes, and updates frequently in close alignment with business objectives. That's quite a mouthful. What does it mean? So it means um, the important objective for the business or any organization that's running is make sure that it brings new features and new fixes to their product. For instance, if you are a tax filing site, you want to bring in automation where users upload their form 16, and it will automatically read those things and tell them what would be their likelihood of getting returns or how much they have to pay to the IT. Okay, so that means developers have to write code and incrementally check it. You cannot write everything at one time and say that everything is working. That will be a big disaster, right? So you have to make changes incrementally. So first thing is you have to launch your product. What is shortening systems development lifecycle? Systems development lifecycle is you have plan, build, design, and all these phases, right? Plan, build, design, and all these phases, right? So first you plan what kind of product you want to do. Then you design, okay, what kind of application I'm going to build, where is it going to be hosted, okay, how many servers I'm going to use, what are the various databases I'm going to use, whether I use MySQL or let's say Cassandra, whatever, and how do I increment how do I deploy this, all these things is your plan. Then you actually start building the application. Meaning you create servers, you deploy your application, you open it, then you test it properly, you test properly and release it to the public. Then you say, okay, this is my website where you can file your tax returns. It's better than the government site, please go and use it. Okay, so this cycle from plan till the release should be really short. You have to get to market as soon as possible, and also once your product is out in the market, you have to new bugs will come into place, meaning people will find some or the other issues, because software is always prone to issues. So then you have to quickly fix them. Okay, and also you have to quickly provide new features to them. if you see these days, every 15 days or 20 days, you will get your updates for your Android apps, right? So that's how fast it has become. Even in your office also, and when I say office, Microsoft Office also, you get a lot of updates. Even for your Adobe, you get a lot of updates. How is this happening? Because of this DevOps practice, which ensures that developers develop their code, and ops team is responsible for testing it, and ensuring the testing is done, and also deploying it in a faster pace. Okay, it's all about decreasing the software development lifecycle to bring the time from planning to go to market. That's what we call it. It's called as go to market time. The go to market time has to be really short. Otherwise, some competitor will come and take over that space, right? And also, you have to make sure it is highly available, meaning your application is always accessible to people. If it's always frequently going down, like government side, what will people do? They will stop coming to it. Of course, for government sites, we don't have any option. We have to go to IRCTC only. But if it's a private website like Make My Trip is always going down, then people will go to Clear Trip, right? So a DevOps is all about these set of practices which will ensure your application is released faster to the market, and also new features are released quicker. Fixes are also updated. People find some bug with some issue, you immediately fix it. Okay, and these are all in alignment with business objectives. What is your business objective? Any business objective is to increase their customer base and provide the right service. Okay, so what it is? So if you go into a little deep, it's a culture that aims to create better coordination between development, QA, and operations team. Okay, so in the traditional way of working in IT, so it used to be like this. Okay, you always have your the development team, which actually build code, which actually write the code. Okay, and then you have your ops team. Okay, operations team, IT operations or operations, whatever you call it, operations team, which is responsible for taking that code and build putting it in the servers and managing it. Okay, that's the ops team's work, right? So development team and operations team, you have these two departments. And of course, you might also have heard about QA team, right? What's a QA team? QA team is something that tests the code and make sure everything is fine. But more often than not, QA is always considered as part of development team only. What happening? Okay, QA is mostly considered as part of development team only. So earlier, what used to happen? These teams work in silos, in separation, right? Okay, operations team is responsible for managing the servers, updating any fixes, doing operating system upgrades, some sort of automation here and there. But mostly, it's about maintaining the servers and the underlying infrastructure. Development is all about writing code, and what they are doing, what development is doing, ops don't know what ops doing, development doesn't know in the traditional setup. Okay, then what happens? Development team develops a code, and just the release date is, let's say, 10 days from now. Just before 10 days, they inform the operations team, okay, we have this new application that has to be launched by today is what, 13th, right? 12th, right? So they say, oh, by 22nd we have to launch this application. I don't know what you will do. This is the code. Take it and deploy. Okay. And then operations team were in like shock. What? 10 days? I have to make sure I have all the servers. I have to make sure I build various environments, because you don't directly release to the public. Before that, you have to test it internally. So you have environments like dev environment, staging environment, QA environment. Okay. Without those environments, you cannot push it to production environment. So you have to create all these environments, and there is a lot of work. And they give the code and you deploy, and it fails on the dev servers. Initially, you build it on dev servers, and you say, hey, everything is failing on the dev servers. And the development team typically comes back and says, it works on our machines, so must be some issue with your servers, because they might not have properly documented this, or they might not have gave the list of dependencies that are required for this application. That application is failing, and now this a fight between development team leaders and operations team leaders. They always say that, oh, it's always your team's fault, they don't do proper homework. is what operations team says. Development team says, no, 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 you should know at least what to do. Your operations team is bad, and all these kind of fights. They do happen. I've seen these fights also. Okay. Um, but DevOps, what it tries to do is the culture of DevOps. What the aim of DevOps is to bring these teams together. Okay, and from day zero, meaning first day of your development, you start working together. Okay, you three teams work together, and you know what development team is doing, and operations team know what development is doing, and how they can take this code forward, how they can deploy the code. And every day they meet and they know each other's challenges. What is operations team challenges, what is dev team's challenges. They know all these things, and they work in unison. They work as a single unit, and it makes I mean, this culture uh, brings better results, and your product can be released faster into the market. So DevOps is all about this, bringing these teams closer in terms of the culture, in terms of their coordination and synchronization. Everything is done together. So in this way, your go-to market rate is faster. You can release your product faster. You can release the updates to the products faster. Okay, that's what DevOps is all about. So dev in development and ops in ops makes it DevOps. Okay, that's the that's DevOps in very short nutshell. But there is a lot of thing to do that, right? Like you have the right people, you have the right culture, but that doesn't work. So when the dev team builds the code and the ops team has to release it, there is a lot of what do you call automation that needs to be done to make things go faster. Okay, so once the development team builds the code, it has to go through the testing process. It has to go through some security scans and all these things. So ops team, what it has to do is it has to make sure that these things are automated right from the moment the developer submits his code. It is going through automated checks. It is deployed in the dev environment. It is automatically sending emails to developers about the results and all that stuff. Okay, and that's why they brought in a new team called as DevOps teams. So it's we are not doing operations the traditional way, but we are doing it in differently. We are managing the applications differently. We are deploying the applications differently. Everything is an automation mindset. And also there is another set of teams called as SRE teams. Sometimes some organizations might have both DevOps teams and SRE teams. In some organizations, SRE teams are also responsible for DevOps practices. Okay, so SRE teams basically, or site reliability engineering teams, are basically responsible for production systems. Okay, they make sure the production systems are uh, running well. They are always monitored. You have pre auto healing scripts and auto scalability and all these stuffs. But in some organizations, these people also take care of the dev environment, staging environments, and making sure they're running well and developers are able to test their code properly and deploy their code automatically. That's what DevOps is all about. Okay, so in simple terms, it's culture, people, and people, processes, and tools. You need to also have the right set of tools to do this stuff. Okay, so that's why we are here, right? So we have to learn some tools to understand how an organization can follow the DevOps methodology. Aim of adopting DevOps culture is to build and release software quickly and maintain applications with high availability and resiliency. So resilience is nothing but the ability to recover from failure. Failures are always there. Okay, you always are bound to fail in software applications. Failures are always there. Some server will not work. Some database is not working. So you have to make sure even if there is an error, it has to come up faster. Did you ever see WhatsApp going down? It did go down a couple of times, right? But the amount of time it took to recover is very short. Like it came back in like a few minutes. Okay, that is what resiliency is. Okay, and what's DevOps? What it's not. DevOps is not a technology or a tool. So it's not like a single tool that you will learn in 1 month and you are a DevOps engineer, right? It's, as I told you, it's process plus people plus tools. So you have to bring these three things together, and only then, in fact, you can achieve the DevOps mindset. And in fact, there is a book by Google called as SRE, Site Reliability Engineering. In that they say that DevOps itself is not a job role like a software engineer. I mean, ideally they say DevOps should not be like a DevOps engineer. There should be an SRE team which is also responsible for making sure DevOps culture is followed. And the DevOps culture is not only followed by ops teams but also the other teams. But in real world, there are positions called as DevOps engineers. There are teams called as DevOps teams which are responsible for uh, ensuring that your code is promoted faster to production and it is properly tested, properly automated, and your infrastructure is properly created automatically. All these things will be taken care by DevOps teams. Okay. Okay. So this is a small overview of the DevOps life cycle. Let me open the bigger image. You'll get an idea. Just a second. Uh, okay. So yeah. So you have your plan stage. So if you talk about software development lifecycle, I told you there are phases in software development lifecycle, or any systems development lifecycle. Even it building a metro railway station, metro rail connection, or even building a multiplex. Everything goes through a system lifecycle. There is plan, there is design, there is build phase, there is release phase actually, which you could also call as maintain phase, and then there is the monitor phase. You have to monitor continuously for any kind of issues, right? So in the plan stage, you do market research and requirements gathering. There are some tools like Jira which will help you do that. Okay, we don't have to focus on this phase because that's an architect's job. Then you have the design phase where you actually build the infrastructure architecture. There are different types of architectures: three-tier architecture, n-tier architecture. Okay, and then the build phase. In the build phase, there are a lot of things to take care of. One thing is IT infrastructure. So there are two ways you can do it. You can do it on cloud or you can do it on on-prem data center. And also within the cloud, there are multiple uh, things. You can go for IaaS or PaaS or SaaS. Mostly in these two things, people will go. And within these things, you have a lot of options, right? From Azure to Google Cloud Platform, DigitalOcean, AWS, all these things are there. And of course, when you talk about IaaS or even on-prem data centers, you also have to understand about the operating systems, right? So why am I showing this? We have to learn at least one of these things in each element. Okay. So we'll not talk about the plan stage and the design stage. We are not going to design as as DevOps engineers. We need to focus on these things. So here we are going on cloud. We're going to learn Azure. And within the operating systems, of course, Mac is also like Linux, so don't have to worry about. Even Solaris is like Linux. These are all called as Unix-like systems. So we'll focus on Linux in our course. Okay, we'll learn Linux first, then we'll learn the concepts of Azure, because without learning Linux, you cannot maintain virtual machines on Azure. All right, or even for that matter, anywhere, even on on-premise or anywhere, you need to understand how Linux works, because Linux is the predominant server in the market for hosting applications. Okay, so after the build phase, within the build phase also you have something called as there is some automation aspects, infrastructure as code. So let's say you are building applications for your client on cloud, and today your client comes with the requirements like I need 5 web servers, or your architect after working with the client comes to the conclusion that there will be 3 different environments like dev, stage, and production. Okay, in dev environment, it is only for testing. So you will use two web servers, two app servers, and one DB server. Okay, in stage, staging has always to be inconsistent in line with the production servers. So he says four web servers, uh, four app servers, and three DB servers. You have to build on cloud. Okay, same in the production environment as well. Just giving a basic example. All right, it doesn't mean it looks like this only. There might be other aspects as well. Okay, so you created all these things manually on your cloud, like logged into cloud portal and created all these things. But tomorrow another client comes. This is, let's say, client SYM, whatever. Okay, and then another client comes, client AXY. He says he needed different same setup, but there is no web and app servers this time. It's only just web and app are combined. So he says he need two web servers, and here it's six web servers and, you know, 5 DB servers, something like this. Okay, so again, you have to go to the Azure portal, create each server individually for these so many servers. Like each of them might have different specifications. For example, in dev servers, you can have small computers like two CPUs and 4 GB of RAM. But in production, you might to have four CPUs. Each machine should have four CPUs and let's say 8 GB of RAM. And database servers should have more memory, so four CPUs and 12 GB of RAM. So you have to configure all these things manually for so many systems. If you have to do it manually, your rate of, provisioning will decrease, and maybe within the same project you will have new requests, new environments have to be spin up. They say we need a training environment only for training people. Then again, you have to go into Azure portal and create them manually. So that becomes a lot of manual tasks. So you have to automate creating infrastructure through code. You write some code, you just uh, run some commands, and the code should be created. Of course, you'll change some parameters. Like earlier you used to give 4, here you will give 6. Okay, so by changing some parameters, you have to apply the code, and the the infrastructure should be provisioned. So that's what we call it as infrastructure as code. We have ARM templates in that aspect. ARM templates is Azure Resource Manager templates, or you have Terraform, we have CloudFormation. So Terraform can be used for both AWS and Azure. CloudFormation is specific to AWS. Terraform is sorry, ARM templates are specific to Azure. But when you learn Terraform, you can apply it for both Azure and AWS with minor changes. That's why in this course we learn Terraform on how to automatically create infrastructure on cloud. All right. And throughout this thing, you need source control management, meaning you write some code to maintain your Terraform or anything else. All those things should be maintained in a central location like GitHub, Bitbucket, or GitLab. In our course, we are learning about GitHub and how to use Git. Git is a software that helps you to track your software version, and it will put in GitHub. So these tools are used throughout your development lifecycle. So we will learn these tools as well as part of our course. We learn GitHub and Git. Okay, and then software configuration management. All right, so you built these many servers, very good, but each of these servers requires some sort of software to run. For example, web servers need Apache. Okay, database servers need MySQL or MariaDB or some kind of database software. App servers need Java or something like Python or something. So you have to install software individually on these machines, not your application code, the prerequisite software. So if you have to do it manually by logging into each of these servers, that will be a hell lot of a task. And remember, your work will keep on increasing every day, so manually doing is a big no-no. So you have to create software configuration, or some tools which will automatically deploy the software on these machines, automatically install the software on these machines, automatically make software configuration changes. Okay, there are a lot of tools in the market like Puppet, Chef, Ansible, and also we have Microsoft's software configuration management tool, SCCM. Okay, System Center Configuration Management. But again, Ansible is the leading product in the market today in terms of software configuration. It's easy to use, easy to learn, and also it is much flexible. So in our course, we are going to learn about Ansible and how to deploy, how to configure your servers, okay, using Ansible. That's about the software configuration and infrastructure as code. And of course, even when we build Ansible playbooks or anything, we have to store it in a central location for your entire team to use. So we still have to deploy that into, uh, store it in the GitHub. That's the software configuration management part. And maintenance part, once you build your application, once you deploy your initial code, you have to make sure your developers can continuously create new features and put them in the servers. Okay, for that we have the concepts of continuous integration and continuous delivery, and there are a lot of tools to do that. We have Jenkins, we have GitLab, Travis CI, Go CD. Okay, these are some of the CI CD tools. In our course we'll focus Jenkins because this is an open source tool and also very popular in the market. Okay, so we'll learn about Jenkins in our course. Okay, it's about, double, as I told you, from the time developer checks in the code, it has to directly deploy into the servers. That part should be taken by CI/CD. Okay, and we will learn about Jenkins on how to configure CI/CD so that from the time developer check the code to GitHub, it is picked up by Jenkins, and Jenkins will do any processing that is required and deploy onto servers. Okay, that is continuous delivery. CI/CD are, one single unit. In fact, let's bring them together. Okay. Then, apart from virtual machines, you also have to learn about containers. So, containers are also a way of, containers are mini virtual machines. Okay, so virtual machine is a, it's like a server. It has its own operating system and all. A container is also like that, but very lightweight, and a single virtual machine can run tens of containers. Okay, so we'll learn about Docker as part of containerization. We'll learn about Docker, and there is a concept called as Kubernetes, or there is a platform called as Kubernetes, which is an orchestration platform which works with Docker containers. This is a very advanced topic, but in our course we will learn the basics of Kubernetes. Okay, just a 1 day course about how Kubernetes looks and all that. We'll learn about Docker, and then coming to the monitoring. Once your application is built, you deploy the code and everything is going well, but there are always some or the other issues that are coming up. So you have to monitor your application. So for monitoring, you have a lot of tools like Azure Monitor, you have Nagios, Prometheus, Splunk, PagerDuty. Okay, PagerDuty is an alerting mechanism. So in our course, we are going to focus about Azure Monitor because we are anyway learning Azure. So we learn about how to monitor resources with Azure Monitor. And also I'll tell you what are the other tools and what is the mechanism of monitoring, like what is an on-call system. All these things we'll discuss. Okay, that's part of the monitoring and alerting system. So this is your entire life cycle, and each life cycle we are covering at least one uh, one topic, including the operating system, which we go deeply into it. Okay, so this is, if you ask me, this is the most important for you in this today's class. Okay, it's about what we learn, and of course I'll tell you the basics of, each of these concepts. As I told you, we'll discuss about what cloud, the theoretical part of the cloud, and when we talk about operating systems, we talk about the operating system file systems, you know services and all these things. All right, right, any questions here? No questions? All right. So I know this could be little overwhelming to you, little threatening, scary as well. But I put it in a neat format where you can see what all is covered in our course. Okay, so we'll learn about software development lifecycle and various basics of IT operations. We understand software development lifecycle, IT architecture, networking, and environments. So the first week is all about, learning about your, mm, what are the various phases in your software development life cycle, which team comes into picture, and then we'll understand the IT architecture. How is the applications configured? What is a three-tier architecture? What is an n-tier architecture? Okay, what is a microservice? And networking, very important aspect. A lot of developers or a lot of DevOps folks also don't give attention to this. So we learn about what is a network, what is a subnet, how do you provision your subnets, and how do you create what is DNS. We learn about all these things, and we learn about various development environments like dev stage and production. Okay, then we learn about operating system. We learn about Linux. As I told you, it's the predominant operating system for running servers in the cloud. Okay, and not only in cloud, even on premise also, a lot of servers are a lot of applications use Linux as their operating system. Okay, within Linux we'll understand about the file system. How do you navigate from, because Linux is basically a command line server. I mean, it's also a GUI server. I mean, it also has a graphical user interface. For instance, the computer you're seeing is a Linux machine. I'm running Ubuntu on my machine. Okay, Ubuntu server will not have all these things. It will only have uh, something like this. You will only have command line interface. You don't have any file editors, you don't have browsers, nothing. Everything you have to do through command line in a server. Okay, so that's why we'll give focus to Linux and understand how you manage the file system, how you can go from one directory to another directory, how do you edit anything in your Linux server, what is a package or software application, process, service management. We'll understand some bits about networking in Linux. Then the cloud part. So within the Azure, we learn about how do you manage accounts, how do you manage your resource groups, identity and access management, virtual networks, VM, storage, and DNS. It's at a very high level, but each of them have a lot of other topics to be covered. Okay. For example, VNets have subnets and routing tables, security groups, all these things we'll cover. And virtual machines is a big topic as well. All right. And then comes the infrastructure as code. How do you deploy code onto how do you create infrastructure on Azure without actually going into Azure portal, but programmatically through commands, through code, you have to build uh, Azure resources. Of course, we'll also learn Azure CLI, which is a command line tool. Then coming to software configuration management, as I told you, we'll focus on Ansible and we'll learn about installation and configuration. What are the ad hoc commands, modules, playbooks, variables, and inventory. Don't worry if you don't know about any of these things. These are part of Ansible. We'll learn all these things. Okay. So the next part is source code management. How do you manage all these codes, source code? So how do you install Git? How do you configure it? How do you track versioning and all these things, merges? Okay, and continuous integration and continuous delivery, you will learn using Jenkins. How do you install, how do you configure? So some people ask me, why don't we talk about Azure DevOps? Azure DevOps is another CI/CD tool, but we are learning Jenkins because here you know everything from scratch. You know how to you will know how to install Jenkins on the servers, how to configure it, and what happens in the backend. You can see everything in a Jenkins one. Whereas if you go for Azure DevOps, it is a SaaS product again. Everything is managed by Microsoft underneath. You don't know what's happening under the hood. So that's why we chose Jenkins, and also it's very popular. Then containers, Docker is the most popular container or container tool. So we'll learn about Docker. How do we install? How do we configure? What is a container? What is an image? How to build images and volumes and all this stuff. Okay. Then our container orchestration, we'll learn Kubernetes. But I told you it's a 101 course, meaning very high level. Just a half day or a one day, half a session or one session course where we just talk about basics of Kubernetes. And when it comes to monitoring and alerting, we'll cover Azure Monitor. And important thing is we don't go linearly, meaning first we don't cover all the topics here. Maybe we'll cover most of these because this is theoretical. Maybe we will cover all these things, but when it comes to other topics, we'll not go one after the other in sequential manner. For instance, you might learn some basics of file system and navigation and all these things. Then you have to, of course, start learning about cloud, because you will practice everything in cloud. Everything we learn in this class, we will practice in cloud only mostly. Okay, maybe Terraform you will create on your own machine, but you have to deploy it on Azure anyway. Okay. Of course, GitHub is a third-party tool which is not hosted on Azure. It is also owned by Microsoft. It bought it recently. Um, so yeah, you'll do everything on Azure. That's why we'll first start Azure. We'll understand the basics of virtual machines and how you can start learning Linux. Then we'll move to Terraform, how you can do automatically. Then we'll learn Git, how do you save the code of all these things you created. Okay, so we'll not go in sequentials. We will go backwards and forwards, but we will cover all these topics. Okay. So I know some of you might have some questions, but yeah, let me complete this thing and we'll go for the questions. So our course is DevOps with Azure, not Azure DevOps. Why am I focusing on this? See, Azure DevOps is a separate tool like Jenkins. Okay, in the picture I showed you uh, here, I did not put the Azure DevOps, but Azure DevOps is something like these tools, like GitLab CI or Travis CI or Go CD, but not part of Azure. I mean, it could be, it is a Microsoft offering, but it's not completely part of Azure. It's a separate tool. So we are not learning Azure DevOps. We are learning Azure Cloud and DevOps technologies. That's the important part. Okay. So Azure DevOps is the name of is the name of a suite of applications such as source code repository, project. So it's a combination of your GitHub. It's a combination of your GitHub and Jenkins in one word. Okay, but we are learning these two tools separately because, as I told you, when you learn Jenkins, you will learn more about what happens behind the screen, what's happening in the build server. That's why we are learning Jenkins. Okay, that's why I'm saying we'll learn about GitHub and Jenkins instead of learning Azure DevOps. Okay, so your course, you cannot say your course is Azure DevOps. It's DevOps with Azure. Typical of Microsoft to confuse everyone, they named it as Azure DevOps. Right. What should you have to join this course? So, a lot of people ask these questions. So based on the frequently asked questions, I put this list here. So you need to have a computer, of course. You need to have system administrator rights. And please, please, please do not join the calls with your mobile phones or iPads. I know you like to lie on the couch and, you know, listen to my class, but sometimes you might have to learn something instantly, and doing it on the computer is much better. Okay. uh, what kind of subscriptions do you need to have? You need to have a Azure free tier subscription. Okay, so Azure offers you 1 month free tier where you can use up to 13,000, I guess 13,000 worth of money to create servers or hard drives or networks or anything, and you can delete them when you're not using. But our course sometimes goes beyond 2 months. At least it runs at least for 8 weeks, but sometimes it can go beyond that as well. So second month also we need a free subscription. You don't want to pay bills. So, and one catch here is Azure free tier subscription needs a credit card. All right. So you need to have a credit card to subscribe to Azure. So please make sure you have a credit card, or you ask your friend, your partner, or your brother, anyone. Even if you fought with your friend, patch up with him for the credit card and create the free tier subscription. I'll tell you when to create. Don't create it now, because then once it once the 30 days is gone, you have to again recreate it. Okay, and there should be a backup Azure subscription, meaning after 1 month of our course you'll have to create another subscription to continue practicing. That will be useful even after the batch is over. Even after our course is over, you can continue to learn. So a secondary account is also required. For this, again, you need a different credit card. Okay, so again, if you have one credit card or two even if you have your secondary credit card, I would request you to ask your friend to create this account for you from a different IP address. We have noticed that Microsoft is blocking some free tier accounts if they're created the second time from the same account. So just be careful about that. Okay. uh, so that's another requirement. And what are the other services? We need access to GitHub and Docker Hub. These are all free. Okay, you don't have to even have credit card, or you don't have to give any. Just create a username for all these things. Okay. uh, Freenom is a DNS thing where you can create your own domain name, like a website name. Not a website name only. Okay. Then what kind of software you need on your system? So I told you, right, you should have a computer, and you should have system administrator rights on the computer so that you can install these things. Git bash and VS Code is to edit the code. Okay, you'll write some code, you have to edit it, right? um, and most of the things we do it on the cloud, we do it on Azure cloud only, but we need at least these two softwares on your machine. That's why system administrator rights will be good. Okay, if it's a Windows machine, 4 GB with an i3 or quad core is good enough. If it's a Linux machine, even lesser capacity will do. Okay, and personally, what do you need to have in this course? Appetite for learning, quality time for practice, active participation. Okay, every day you need to give some quality time besides the class. After the class, you need to spend some time, practice, and next day come up with questions. That's what active participation means, right? You have to ask me questions, you have to uh, you know give me new information or whatever it is. That's from your personal side. And skill side, it would be great if you already know Linux or programming. Lack of the above is not a hindrance too. It would be great, I mean, superb. If you don't have also, don't worry, because we are going to cover in this course. All right, so people ask me, do I need to know programming? No, not at all. If you know it, it's awesome. Okay, do we do coding? Do we do programming? We don't do programming, but we do coding. Okay, there's some difference. Coding is using the existing code patterns and modifying to our requirements, whereas programming is creating something completely new using C or Java or something. So we don't do programming, we do scripting and some coding. All right, so we do a lot of typing. It's not about UI based things. Most of the Terraform or Ansible or even Docker we have to do, or even Linux for that matter, everything is command line or coding only. Okay, you'll do a lot of typing, you'll get used to a lot of black screens like Linux servers and your Visual Studio Code editor, but no programming as such. Also, if you know something like Python automation, that would be also awesome, but not a prerequisite, not a mandatory thing. Okay, one more slide I have, and then I'll give it to you. Okay, so this course is designed for both the fresher to IT industry, I mean, meaning you might be inexperienced but not exactly in IT, and also for those already working in IT. So you might be already working in IT, maybe in a quality assurance role or a project management role, or let's say a production support role. And it covers a wide variety of processes and technologies. So as you've seen, we are going to cover a lot of things, everything from basics, of course, you don't have to worry about that. While this course offers a lot to learn and upskill, it's all your enthusiasm to learn and practice that lands you in the right role. So I will do my part. See, my part is very minimal in your own journey. It's all about you grabbing it up, and enhancing your skill set. And as the banner here says, you learn, you implement, and you excel. So simply attending my classes won't take you anywhere. You have to implement them. You come back to me with questions. Not everything. I mean, what I mean is you have to have that mindset to troubleshoot yourself. Let's say you're practicing something. I gave you some task, and after running initial two commands, it throws an error. And if you immediately stop the practice and say, okay, I will ask Kiran tomorrow, that's not a good approach. You have to try to troubleshoot that. You have to read the error message. It could be very simple error message, like you're missing a simple semicolon, or you're misspelled something. Okay, so I've seen this attitude also. Even people who are experienced, the minute an error comes up, they kind of come back to me, or they don't try to troubleshoot. It might be a very simple issue that you might be in a wrong folder, or you might have given a wrong command. Okay, so that should also be there, the attitude to troubleshoot. Okay, um, that's about eh, that's the entire demo for today. Okay, so I'm open up for any questions. No questions? None at all?
Hi, Kiran.
Hi.
Yeah, my question is like, do we need to cover developer course before joining this, like 204?
Sorry, what is that? Developer what?
Do we need to cover 204 course before learning about DevOps?
Not really. See, this course is not aimed at any certification. As I told you, total freshers can also. I mean, this course is designed in such a way that even freshers could also follow that. Okay, we will go everything from basics. So if you know something about Azure or if you know something about Linux or anything, that's useful. But you need not really worry about it. We'll go from ground zero. So. Uh, Absolutely not required. But only thing I request everyone is that once you attend the course and every day we have classes, take some time out and practice them. Only then you will learn, and you can learn, you can understand the next concept better. Okay. Without understanding, for example, Linux properly, you cannot understand Docker properly. Without understanding Docker, you cannot understand Kubernetes. Of course, Kubernetes is not a big part of our course, but if you don't understand some concepts, other concepts will become difficult for you. If you don't understand the cloud architecture, you might not understand the CI/CD and all that stuff. So we'll cover everything from basics. I'll tell you the concept behind it. Our courses will be mostly, our classes will be mostly hands-on only, like very less theoretical, but enough theoretical knowledge as well. Only, practical knowledge will not be good, right? You need to know the theory behind it as well.
So
Yeah,
by
no pre.
using this course, we can attend a DevOps certification exam.
Which DevOps certification? See, the thing about
But I
DevOps,
don't remember. Is it 400, I guess?
if you're talking particularly about Azure, I would say no. Because as I told you, Azure DevOps AZ400 course certification is more towards Azure DevOps, which we are not covering. Okay, so you might have to spend some more time learning Azure DevOps. We will learn about Jenkins. Based on Jenkins, you'll easily understand Azure DevOps, but you have to practice for some 15-20 days on Azure DevOps, and maybe you can attend the certification. See, DevOps is a wide area. Okay, DevOps is a wide area where you have wide and also deep. Wide in the sense you have a large number of areas to cover. As I told you, um, you have continuous integration, continuous delivery, you have container orchestration, containers, you have cloud, you have you know each of these clouds have their own certifications. You have Linux, operating systems. You have each of these have some certifications or the other. For example, these don't have; these are part of AWS. You have Terraform, which has a certification. Ansible has a certification. Okay, I'm not sure about Jenkins, but Docker has its own certification. Kubernetes has its own certification. By the way, I'm certified Kubernetes administrator. Kubernetes is the um, is the very bleeding edge technology, the latest technology. So you need to know Dockers very well. And of course, with the introduction I give, I'm sure you will learn it yourselves. Okay. What else do we have certifications for? I think Splunk has a certification of its own. So there are a lot of certifications. There is a lot of depth and breadth. Depth in the sense how deep you can go into each topic. Breadth is like how many certifications, how many areas we have to cover. We have to kind of cover the software source control management, version control, these all tools, right? So everything has one or the other certification. So this is a generic DevOps course that covers wide variety of core topics. Maybe you could go for something like Terraform engineer course certification, or Docker certified Docker administrator course, or you could go for Azure 900, which is the fundamentals course. Or once you get some good idea and prepare for another 10-15 days, you can go for AZ 300. But don't think that right after the course you can do a certification, because as I told you, this course is more on hands-on rather than keeping in any certifications in mind. It's about, if you're already working in a QA job, or if you're just trying to get into a job in IT, it will give you that nice overview of so many areas. So it will make your profile look really good, but not aimed at a single certification. That's my point.
Okay, thank you, Kiran.
Yeah.
Kiran, do you show any practical environment, live environment kind of thing, which will give more exposure to the live environment, right?
What do you mean by live environment, sir?
any client specific environment? How do you people perform the activities and all such kind of things?
I wish I could show you, but the minute I show you, my job will go and maybe I'll have jail time as well. I cannot show any client, and in fact, anyone who says they are showing some client environment, that's one thing not accurate. Okay,
Mhm.
not proper. And second thing, they might not be the actual production environments. But don't worry, we'll, as I told you, there is a lot of areas. There are a lot of areas we need to cover. So we'll cover each of them individual pieces, and towards the end, when it comes to CI/CD and all, I'll show how it all boils down to, uh, you know. Um how these various components come into picture together. Okay, but I would not give you that false assurance that I'm going to show like production like environment. It's not possible to replicate as well, uh, for various reasons. But hey, thanks to cloud, you can do a lot of things which we could not even imagine 10 days 10 years ago. For example, I can create 3 web servers or 4 web servers and a database server and connect them together, use Terraform to build these things, and use Jenkins to do the CI/CD. We will do all these things, which is like almost production like, right? But if you
Okay.
want to show me some real world scenario, I will not be able to do that.
Okay.
But we can.
And this
We'll,
this
yeah.
particular DevOps, right? Yeah, I understand that point, but this particular DevOps is going to be a generic one, right? It is not specific to Azure or AWS or Google, right?
No, no, we are doing it on Azure, right? Everything will be on Azure.
Oh, okay.
Yeah, this course covers both Azure as well as DevOps.
Okay. Okay.
Yeah,
Thank you.
you're welcome.
Another question, Kiran. So you might have seen many people, right, under your training and all. So usually, how much time it will take for a person, normal person, to get into the job once they get trained? It's all depends on the practice and all. I agree, but on average, how much time it will take for a common person if they really put some effort?
Uh, Honestly, not many students have kept in touch with me post the courses. Some people ask me questions, some people prepare for the interviews. But yeah, there are a lot of people who are placed in freshers also, or freshers with 2 to 3 years experience also got placed. Um, Again, see, practice and all is one aspect, and how the market is looking at. But these days, you have good amount of requirement for DevOps engineers. But see, when it comes to job, one thing is your skill. The second key part is how do you communicate in the interview. That also depends, right? You might know everything very well, but if you're not articulative enough, these are some of the factors. But I would say anytime, anywhere between 3 months to 6 months, if you continuously, I mean, after the course also, if you continuously practice and continuously, you also have to read, because uh, right, we cannot create real production scenarios, but why can't we read about real production scenarios? We can read
Hmm.
about that, right? We can read about that and learn understanding. So minimum of 3 months. Okay, if you continuously practice and read through the blogs, watch some YouTube videos. These days everyone comes onto YouTube and tell us what they're doing in their production environment. I mean, they'll not show you the production environment, but they're telling what they do. So you can draw a mental picture of that, and you can showcase that in the interview. Okay, like what you understand. See, everyone, and another important aspect is, no one expects you to be a champ in all these courses. uh, let's say if you're rating yourself on a scale of 10, no one expects you to be a 9 or 8 on all these areas. Let's say you are a 7 on Terraform. Your Git, some things are like bare minimum, like you need to be very good with operating system, and you need to be very good with version control, Git. Okay, this should be, you should be somewhere like 6 or 7. Okay. um, but with things like Terraform, Ansible, let's say you're 8 on Ansible, but you're only a 6 on Terraform. That's fine. Okay. you are another 7 or 8 on Jenkins and just starting with Docker, it's also fine because Docker is just people are picking up right now. And if you know some monitoring tool, that's good. Okay, you need not be a champ in all these areas. So you have to pick up your own areas. I would suggest CI/CD and containers are like the future. You have to focus on these things. Okay, and learn good amount of Azure. Yeah, you know. Uh, and another important thing you could do apart from practice is speak to the folks in your circles or in your offices who are already working with DevOps roles. I cannot show you as a trainer in a recorded session, but your friends, they might be able to show you, right?
Agree. Yeah.
Yeah, at least they might not show you, but you could go to their home and just have a chit chat. See, once you learn all these things, there will be a lot of difference after this 2 months course. You might not be able to implement everything, but when someone says we are doing this, you can get a mental picture of, oh, okay, this is what they are doing, this is what we have learned. You can connect these dots, all right? So it's a continuous journey, folks. I always tell this to everyone. The folks in Sri Chaitanya and Narayana lied to us. They said after inter you need not study, but the real study begins after your BTech. So every day you have to study, particularly in this world of DevOps. You have to keep yourself on toes. And even today I have to read a lot and be prepared for every new project, and every day it's a learning, all right? So how articulative you are and how confidently you can present yourself also is a factor. And trust me, there's a lot of demand. With the right amount of focus, you can definitely get it in 3 to 6 months. Okay.
That's great. Yep. Thank you.
Welcome.
Are we going to have another demo session with
No, that's the end of.
continuation? Okay.
Yeah, yeah. The session will start from the classes will start from Monday.
Okay.
Okay, Monday we are going to talk about the basics of IT architecture.
So every day, how many hours it is going to be?
So it is scheduled to be 1 hour 15 minutes, but based on, see, it's more dynamic, right? It's not like I have a fixed schedule of things. I generally go very I don't have a limited set of sorry, what do you say, defined way based on how the course is progressing. Sometimes it might go up to 1 hour 30 minutes, like 7 a.m. to 8:30 a.m. IST. You could book it for your classes every day. Initially it might not take that long, like, because if we are in the middle of some topic, we are discussing, let's say, IAS about our virtual machines of Azure, and we arrive at a practical stage, I don't, and it takes another 15 minutes, I might continue till 8:30, but generally 7 to 8:15, 7 to 8. So 1 hour 75 minutes to 90 minutes every day.
Okay. On average, how much time we need to practice at home? I'm just looking at, time allocation for this course. How much time do we need to allocate?
uh there is, I mean, I cannot say about each of you, but at least 1 hour to practice whatever is taught in the class. Of course, if you have backlog, I mean, 2 days you haven't practiced anything, so third day you have to practice. Or sometimes there is little to practice because more of it is theoretical. I will ask you to read on something. So at least 1 hour, if you could put it aside, quality time. When I say 1 hour, in the 1 hour you're also spending some time on YouTube and watching some videos not related to technology. And another in the same time you're also spending on WhatsApp, but that's not 1 hour. Like you spend a quality 60 minutes on practicing on reading. That would be what is 1 hour for me. Yeah.
Okay. Yeah, I understand.
No, distractions are very common these days, right? So we can't help it. I am also constantly distracted.
Yeah. Kiran, I'm good from my end. I'll log off. Okay.
All right. Thank you so much for joining.
Thank you.
If there are no further questions, we can conclude here and hoping to see you all on Monday. Thank you, Nitika. Mhm.